So, good day everyone. I am Sindrul John A. Bragat, CE4, student number 1 for CE4435899. So, my lesson for today is hydrology and hydraulic process. So, what is the difference between hydrology and hydraulics? So, hydrology is the scientific study of the properties, distribution, effects of water on the Earth's surface, in soil, and underlying rocks. And also, lastly, in the atmosphere. So, next is hydraulics. So, hydraulics involves movement operated by a fluid under pressure. It deals with the application of the fluid mechanics to engineering devices involving fluids. Especially, usually ang ginaano nila is water or oil. Next is hydrologic cycle. So it is a circulation or cycle that controls the distribution of the Earth's water as it evaporates from bodies of water. It condenses, precipitates, and returns to those bodies of water. So muna siya tong, makita na to tong diagram na evaporation, precipitation, tong cycle siya. Next is watershed. So as we all know, if makadug tang watershed, ang mosulod sa utok-utok is usually ka sa report, Manila watershed, it is a basin, no, na nagakollect siya og water. Rainfall, gikan sa rainfall, so it is a ridge of highland dividing two areas that are drained by different river systems. The region draining into the river system, or other bodies of water. It is also called drainage basin. So meteorology is a branch of atmospheric sciences which includes atmospheric chemistry and atmospheric physics, with a major focus on weather forecasting. Next is humidity. Is the amount of water vapor in the air. So next step, makita na to kung sa ka-importante ang humidity sa cycle, sa hydrologic cycle. So this is hydrologic cycle. First, we have evaporation. So water comes from the river, seas, or etc. transfer into a gas or water vapor. Condensation is a process by which the water vapor changes to a liquid. Next is precipitation. Is any type of water that forms in the Earth's atmosphere and then drops onto the surface of the Earth. Interception. When rain falls on the Earth's surface, some of it strikes vegetation, building, and other objects. So this rain is said to be intercepted. So dili siya directly ma-fall sa soil or sa ground. Mawagi siya sa buildings or any other objects. So transpiration is the process by which plants and animals, including human, gives off water vapor through pores and evaporate it. So kita nagahatag and plants og we have water vapor sa system. So, runoff. So, it is flow of water that is not absorbed into the soil. The overflow from the surface to the bodies of water like river. So, ang runoff, para simplify, no, putahin na ulan, yan, na mountain. Usually, ang runoff is kanang tubig na nagadaloy good padulong sa ubos, or runoff kay dili siya directly munuot sa ground. Nagadaloy lang siya sa surface sa mountain or other formations. So next is infiltration. So rain falls into the ground, infiltrates from the surface up to the root zone. So muna na siya naganuot na ang tubig padulong sa ilalom. Next is percolation. From root zone, water will move down till it reach to the aquifer. Muna na siya tong aquifer, itong nag-store sa tubig. So, next is groundwater. Is beneath most places on the land surface. So, this water is contained in the voids within underlying geologic material and water-bearing formations, also called as aquifers. So as you can see in the water cycle, no, evaporation, condensation, precipitation, and actually, interception, transpiration, runoff, pwede na siya magbali-bali sa cycle. Okay, there are times that dili siya mag-hit sa ground, so mas mauna ang runoff. Napoy uban na if dili siya mag-hit sa ground diretsyo, I mean, if dili siya mo diretsyo sa munuot sa soil, runoff. Then, napoy uban, if ever dili siya directly maigo sa any formation sa rocks or soil, maagi siya sa interception wherein agi siya sa building, sa vegetation, other objects. Muna siya. So next, so what is the impact of hydrologic cycle in human life? So imagine yourself without water. Sa pag inom ng tubig, sa pag bawas, something na, it's very hard, no? So hydrologic cycle is connected to the human life. Without water, human and other living things will vanish. Also, water is also part in the activities in daily life: irrigation, hydroelectric power plant, groundwater source, recreational activities, and source of food. So that's why important yun siya, no? Great impact siya sa human life. So next is atmosphere. It's a spheroidal envelope of gas and vapor surrounding a planet. It is retained by gravity. As we all know, diba, na siya sa Earth, di ba naman siya mga lain-lain nga type sa atmosphere. So, the composition of the Earth's atmosphere and most of its physical properties vary with altitude. So, I'll be presenting it. So, troposphere is the part where asa ta nagapuyo. So, it is the lowest zone or part of the atmosphere. It extends from the Earth's surface to an altitude of about 5 miles or 8 kilometers at the poles and 10 miles or 16 kilometers at the equator. It is characterized by decreasing temperature with increasing altitude. So, naga-decrease ang temperature pero naga-increase ang iyang katason. Also, it contains most of our weathers, which is cloud, rain, and snow. Next layer is the stratosphere. So this extends upward from the tropopoles to about 50 kilometers. It contains so much ozone in the atmosphere. So the increase in temperature with height occurs because of the absorption of ultraviolet radiation. So nagainit siya sa banda. So temperatures in the stratosphere are highest over the summer pole and lowest over the winter pole. Ayun. So, mesosphere, the region above the stratosphere. It is, the temperature again decreases. So, sa ato ang stratosphere, nag-vary siya if summer or winter. So, pag summer, mainit jud siya. Then, pag winter, okay, mag-drop ang temperature. So again, sa mesosphere, mag-decrease na po ang temperature niya. Then, aside sa temperature, mo increase po ang iyang height. So, next we have thermosphere. So, lies above the mesopause and is a region which temperature again increase with the height. Okay? Again, nag-increase na po siya. This temperature is caused by the absorption of energetic ultraviolet and X-ray radiation from the sun. Muna siya tong init-init na dyan siya din na part. Lastly, we have exosphere. So, lies above 500 km from the surface. It contains mainly oxygen and hydrogen atoms. So, there are few of them that rarely collide. They follow ballistic trajectories under the influence of gravity. And some of them escape right out of place. So, kani exosphere mo siyang last na barrier sa atong atmosphere. Ayan. So, yan. Exosphere, mga siya ang pinakagawas jud, pinakagawas. So start with troposphere, next stratosphere, mesosphere, thermosphere, then lastly naga-protect jud exosphere. So how clouds are formed? So clouds when form when moist, warm rising air cools and expands in the atmosphere. So the vapor in the air condenses to form tiny droplets in which are the basis of the clouds. So tungod sa water vapor or iba, ganina sa humidity, important role siya para maka-form of clouds. So, you may be wondering why lahi-lahi ang color sa clouds. So, the different colors of the clouds are depending on the light of the sun. The clouds having dark color because the light of the sun cannot pass throughout the cloud. So, ginablock sa cloud ang sunlight. So, dili siya partly na dark, then dili lang siya maabot na portion, like 20% lang yung makaya nga suga, makuan sa sun, then mostly sa clouds na. So you can observe that in the night, the clouds have dark color because there is no light or enough light. So the white clouds, like cotton we see in the light, is evenly distributed in the clouds until the bottom of it. So kana siya makita na to sa adlaw, kanang kuan yun siya puti yun ang clouds. Muna siya to ang sun, ang light sa sun, evenly distributed yun siya sa cloud. So, meaning, the whole cloud kinabot na coveran yun sa light. Okay. So, what are the types of clouds? No, daghan yun siya, no? High-level clouds are composed of cirrocumulus, cirrus, and cirrostratus. So, it has an altitude of 5 km to 13 km from the Earth's surface. So, muna siya ang pinakalayo. Next, we have cirrus. Cirrus is one of the most common types of clouds that can be seen at any time of the year. They are thin and wispy with a silky sheen appearance. Cirrocumulus, among the most gorgeous clouds, these usually form about 5 km above the surface with small white fluff patterns that spread out for miles and miles over the sky. They are sometimes called mackerel skies. So, madunggan na to siya sa, ginaingon sa uban. Because they can sometimes have a grayish color which makes the clouds look a bit like fish scales. So, cirrostratus have a sheet-like appearance that looks like a curly blanket covering the sky. They are quite translucent, which makes it easy for the sun or the moon to peer through. Their color varies from the light gray to white, and the fibrous band can vary widely in thickness. So, purely white cirrostratus clouds signifies that these have stored moisture, indicating the presence of warm frontal system. Next, we have mid-level clouds. So, natay high level, napoy mid-level. So, mid-level are composed of altocumulus, altostratus, and nimbostratus. So, it has an altitude of 2 km up to 7 km from the Earth's surface. So, altocumulus form at a lower altitude, so they're largely made of water droplets, though they may retain ice crystals when forming higher up. So altostratus also, altocumulus form a lower altitude, while altostratus often spread over thousands of square miles and are strongly linked to light rain or snow. So, though they are not capable of yielding heavy rain, it's common for altostratus clouds to morph into nimbostratus. So, nimbostratus, muna siya ang indication na storm or rain, heavy rainfall. No? Nimbostratus form a result over the gradual accumulation of moist area over a large area as the warm and moist area higher up in the atmosphere where it condenses. So there is also lower level clouds. So are composed of stratus, cumulonimbus, stratocumulus. It has an altitude of 0 to 2 km from the Earth's surface. So natay low level, mid-level, and high level. Cumulus, it is the most recognizable out of all clouds. These adorable piles of cotton form a large mass with a well-defined rounded edge, which explains the name cumulus, which is the Latin word for heap. Cumulonimbus is a fluffy and white-like, but the cloud formation are far larger. It is a vertical developing type of cloud whose base grows from 1 up to 8 kilometers. So it is also called tower cloud. So the rain comes and goes with this cloud, but when it does, it came pouring. When you see a cumulonimbus, you know there's a thunderstorm waiting to happen somewhere. So may siya indication na ay thunderstorm or rain. Stratocumulus looks like a thin blanket of stretched out cotton. They resemble cumulus clouds except they're far bigger. The base is well defined and flat, but the upper part of the clouds is ragged due to convection with the cloud itself. Oh, depending on the thickness of the cloud, a stratocumulus will have light to dark gray hues. Hue. So these are the dagway sa mga clouds of cirrus, cirrocumulus, cirrostratus. Altostratus, altocumulus, and nimbostratus. So this is from the same. There siya, pakita dyan lang yung dagway, no? Cirrocumulus, or also known as mackerel sky, is above 18,000 feet. Stratocumulus, 6,000 feet. Stratus, also below 6,000 feet. Cumulus, also below 6,000 feet. While cumulonimbus is above, from near the ground to above 50,000 feet. Ano siya? So as you can see, na 12 to stratus, cirrus. So watershed in its part. Watershed are composed of many parts, including surface water, estuary bay, river, creeks, streams, and wetlands. So also riparian areas, uplands, and groundwater. Wetlands are an area of land that is saturated with water for all or part of the year. A wetland can be a marsh, pond, or bog. Wetlands are typically surrounded by riparian vegetation. They are like giant sponges that store water collected during wet periods, reduce flooding, filter out pollutants, disease, and nutrients, and slowly release the water into the groundwater and rivers, streams, and creeks during their periods. So next is riparian vegetation. Other plants that grow along or near riverbanks, lakes, and wetlands. The roots of riparian plants stabilize stream banks. So, ang important role sa riparian plants kay gina-prevent niya from erosion ang kanong formation sa surface of water. So, ay, surface water. Sa, kato siya, gina-prevent yung erosion and silting in the streams and river channels. So, spongy soils in riparian areas slow and store water, reducing flooding and later releasing water to aquifers and streams. So, very important role na siya kay muna siya ang nag-prevent na maguba ang formation. Groundwater is all water under surface of the ground. It is stored in the soil and it can be found under the ground in deep aquifers or very near the ground surface. Okay. Instruments in measuring precipitation. We have rain gauges. Measures precipitation amount at a given location. Oftentimes measures from individual rain gauge are used to represent precipitation conditions across larger areas. Ground-based weather radars, so it emerged during World War II and have been since used to observe precipitation mostly over land. It sends out pulses of microwave energy in narrow beams that scan in a circular pattern. So, here explains when the microwave pulse encounters precipitation particles in the atmosphere, the energy is scattered in all directions. So, nag-send siya of energy back to the radar. These measurements are used to estimate intensity, altitude, precipitation type, and motion. Earth observing satellites. So, provides frequent estimates of precipitation at the global scale. To do this, satellites carry instruments designed to observe specific atmospheric characteristics such as cloud temperatures and precipitation particles. This is also called as hydrometeors. These data are extremely useful for filling in data gaps that exist between rain gauge and ground-based radar sites. So this is the dimensions for the standardized rain gauge. So the 8-inch diameter rain gauge used in National Weather Service is of standardized design used throughout the world for official rainfall measurements. So it provides uniformity, continuity, credibility of precipitation data worldwide. So there are two types of rain gauge na First is 8-inch. 8-inch jud siya. Then ang depth niya is 20 for the large gauge. For the smaller gauge, we have 8-inch ang diameter pero 7 inches ang iyang capacity, depth. So, ayun. So, the 20-inch depth gauge is the norm throughout the National Weather Service. However, other agencies like U.S. Forest Service often use smaller gauge. It has also an 8-inch diameter funnel emptying into a graduated cylinder, 1.17 inches in diameter, okay, which fits the container that is 8 inches in diameter. So, nakasulod siya. If the rainwater overflows the graduated inner cylinder, the larger outer container will catch it. So, muna siya. Device na siya gamit sa US Forest Service. Okay. So, how do you set up your rain gauge? First, the rain gauge should not be placed in the area that is the gauge should be placed in an area that is protected from strong winds but not bothered by obstacles that could either block precipitation from reaching the gauge or cause precipitation to splash towards it. Important na nga layo ra siya sa mga environments na makakause og disruption sa iyang precipitation. Next, the gauge should be installed 2 to 5 feet above the ground. mounted on the side of a single post. The top of the rain gauge should extend several inches above the top of mounting post. So the mounting post should have rounded, pointed, or slanted top to avoid upward slash towards the rain gauge. Number 3, next, the rain gauge should be installed at a reasonable distance away from the obstacles such as building, trees. So, muna akong sabot. If a tree is 40 feet tall, the gauge should be placed at least 80 feet downwind from with it para ma-protect para ma-avoid ang potential na blockage sa rain gauge. Avoid large obstacles that could block precipitation. Avoid mounting the rain gauge where sprinklers or other sources of artificial precipitation can affect the data. For example, kung naka-rain, kanang sprinkler, sa pula, dire ang rain gauge niyo, naka-sprinkler dire. May tendency nga mag-precipitate ni tungod adtong artificial na gibuhat or other like mga hose o mga gardening stuff niyo mo. May possibility nga sensitive ni siya, maka-cause siya precipitation dire sa unit. So, make sure the top of the rain gauge is level. Move the rain gauge so the heavy rain could not splash into the gauge from any nearby surfaces. Dapat secured ang imo setup. Balik lang. So, the estimating the missing data and adjustment of records sa tong rain gauge. So, we have here station year method. In this method, the records of 2 or more stations are combined into one long record, provided stations records are independent and the areas in which the sections are located are climatologically the same. Dapat climatologically the same. The missing record at the station in particular year may be found by ratio of averages or graphical comparison. So in example, sa station year method, in a certain year, the total rainfall of the station A is 75 cm. And the neighboring station B, wala siya record. So, missing data. But if the record of A and B are 70 cm and 80 cm respectively, makuha na to ang missing data niya by ratio and proportion. By simple proportion lang, kuha na to ang station B. Next is normal ratio method. If sa station year method, nag-ratio and proportion siya, dire, mo gihapon. Pero with addition na siya sa average. For example, rain gauge system D was inoperative for a part of a month during which a storm occurred. So the storm rainfall recorded in the 3 surrounding station. So given na 3, natay 3 ABC which is present, ang D ang wala. So ang ABC na siya 8.5, 6.7 and 9 cm respectively. If the record of the station record for the stations are 75, 84, 70 and 90, so makakuha na to na siya by ratio and proportion and averaging. So first, nganong 1/3 kay ABC lang ang naay data. Times nimo siya sa kana 8.5 over 75 muna siya ang ratio times 90 which is from D atong 90 cm plus, so we get 9.65. So double mass analysis. So the trend of the rainfall records at the station may slightly change after some years due to a change in environment or exposure of a station, either due to coming of a new building, planting trees, or cutting of forest nearby. So, kani siya, ang double mass analysis. na siya process or calculation in order makita ang missing data tungod sa disruption sa lugar, na changes sa lugar, sa environment, tungod sa building, something no? So here, pakita na kung saan pag-solve. So, in the example, as you can see in the left table, muna siya ang given. Okay? Muna siya ang given. So, in order to solve the cumulative annual rainfall, muna siya ang cumulative actual rainfall. Ang buhaton dire is simply add, by the way, these are 18 years ang ayan duration sa kuan, then 18 stations. So in order to solve in the right side cumulative annual rainfall, ang buhaton lang nato is simply add them all. So first, if 1953 imong gusto makuha, you will simply add 30.5 plus 38.9. Next is 1954. Ang buhaton lang nimo kung sa tong data na nag-gather dire sa 1954, i-add lang nimo siya para sa cumulative. So 30.5 plus 38.9 plus 43.7 resulting to 113.1. The same sa annual, the same sa cumulative sa 18 stations. No? 22.8 plus 35, 57.8. 22.8 plus 35 plus 30.2 resulting to 88. So, mula na siya guys until 1970. Next is, kita na ko ningon siya diri na ay changes. Determine the record for the period 1952 for the change regime. So, regime. Na, as you can see, in 1958, nitaas siya. 49.3, 36.1. So, murag, dili siya reasonable. So, it can be seen in the figure that there is this distinct change in the slope in 1958. So, ang buhaton jud nimo anis para sa calculation, i-plot nimo na siya. So, to make records prior to comparable to those after change, the earlier records have been adjusted. So, as you can see, in 1952 to 1957, not including 1958, kay dira man siya nag-change, di ba? So, 1952 to 1957, isa po na siya. So, slope nimo na siya. Actually, by sloping it, dapat diri ka sa 1958, kay mo na yung first triangle nimo. So, we have here, pila man eh, 1, 2, 1, 2. So, 250, 250 here, 250 siya over babaan eh, which is 200. So, 250 divided by 200, we get 1.25. So, M1 now is our slope 1, 1.25. Next, sa change from 1958 to 1970, nag-change, di ba siya? So, from 1958 to 1970, multiple triangle, we have here, start ka, 0 na po siya diri na part, 0. So, So, 300 over 350. Okay. Nganong 350 man kay di kan diri, so 1, 2, 3. Then diri siya nag-stop sa 50. So 3.350, or you can say pwede lang 3 over 3.5. gawas is 0.85. Round up na siya to 0.9. So, again, ang i-change ni mo diri is ang starting. Kay, since ang 1958 to 1970, nag-change siya, so ang i-adjust ni mo is ang starting niya. So, in order for that, 1958 nga cumulative rainfall, which is kani, 554.5 minus nimo siya sa 1957. Why 1957? Kay 1957 jud siya. Dili siya in 1958. Kibali kana na duration magbalik pa kag isa ka year para makuha jud ang result, no? Ang difference niya. So next, kana na siya. 349.8 cm, 1958 to 1970. Karon, i-change nimo from mag-base jud ka sa year before siya nag-change. Again, sa year siya before nag-change. So nag-change siya 1958, ang basihan nimo 1957. So as you can see, makita nimo no, sa cumulative rainfall from 1952 to 1957, 1957 yung gigamit na 204.7, which is kani 204.57. So 554.5 minus 204.7, 349.8. Again, for adjusting the change due to change in environment, i-adjust nimo ang data. Adjust nimo ang data sa cumulative rainfall from 1952 to 1957. So we have gikan 1952, ang total niya makuha is 204.7 times nimo siya sa slope, which is 0.9 over 1.25. Why 0.9 over 1.25? Kaya naga-refer ta sa changes, ay nag-base ta sa 0.9 nga slope. I-divide nimo siya sa 1.25 with respect ta sa 0.9 nga slope. So, muna siya. So, in order to makuha ning 497.4, i-add lang nimo ang 349.8 plus 147.6. So, next, para makuha nimo ang next niya na cumulative or cumulative, ano ba tama ba? Para makuha nimo ang niyan, next niya annual rainforestation, diba, 18 years man ni siya, 1952 to 1970. Para makuha nimo ang 1971 niya, ang buhaton lang nimo is 497.4 divided by 19 years. So, makuha na to 26.2 cm. Dire na siya. Dire na siya sobos. Tama akong pagsabot. Medyo na ako nasabtan. Okay, next. So, mean aerial precipitation. Kani, sabotable naman eh. No? Pero, read lang jud mo guys, ani na topic kay medyo libog siya. Miskin ako maglibog po ko sa calculation adtong asay murag dako nga So, arithmetic mean method is obtained by simply averaging arithmetically the amount of rainfall at the individual rain gauge station in the area. So, muna siya no, P average depth of rainfall over the area. Summation of rainfall amounts of individual rain gauge station, number of rain gauge stations in the area. Bayesian polygon method. The method attempts to allow non-uniform distribution of gauges by providing a weighting factor on each gauge. The stations plotted on the base map and are connected by straight line. Perpendicular bisectors are drawn to the straight lines joining adjacent stations to form polygons known as Bayesian polygons. So, mali siya guys, no? Basa-basahon lang dyan ninyo. Mga ka eh. So, that's all for my report. Thank you for listening.